schematic diagram for the adder. Adder is function to add number in the 4-bit adder. Okay, as you can see, the compilation is also successful. This is the simulation for the adder, 4-bit adder. As you can see, this is output for the adder. As you can see, the output obtained is just the same with the input, since the function accumulator is to store in the input. So when the input is 0, the output is 0, and when the input is 1, the output is 1. Okay, this is 4-bit accumulator. 4-bit accumulator is the function is just same with the 1-bit accumulator. The difference is just the bit, and 1-bit accumulator is part of the 4-bit accumulator, and the compilation is also successful. This is the simulation for the 4-bit accumulator. As you can see, when the input is 2, the output is 2. When the input is 13, the output is 13. When the input is 4, the output is 4. When the clear is 1, the output is 0 because it will clear the...
Basically, we can use the NetWriter circuit that we built in Milestone 2. However, we need to do some modification on it before we can use it for this Milestone 3. The modifications required are: we add control signal circuitry to enable and disable the lights so that the LEDs will only run when the input is high. And we also add done output pin to indicate that the lights have run a complete round. Okay, this is the schematic diagram for the Night Rider light circuit, and this is the compilation report. This is the simulation waveform for the modified Night Rider light circuit. Basically, a prescaler is an electronic counting circuit used to reduce a high-frequency electrical signal to a lower frequency by integer division. The purpose of the prescaler is to allow the timer to clock at the rate a user desires. So, from this Milestone 3, this prescaler is a bit different with the one that we built in Milestone 2. Since this one will generate two outputs with different frequency, which is clock 1 generate 1 Hz and clock 2 generate 100 Hz. For this purpose, we need to build a small prescaler as shown as this one, prescaler 1 and prescaler 2, first before we integrate these two to become our main prescaler. Prescaler 1 with 1 Hz output with Verilog 250 and prescaler 2 with Verilog 180 to make it 100 Hz. This is the compilation report for main prescaler.
Okay, so this is the comparator schematic diagram. Firstly, I created the iterative comparator, the comparator that just compare one bit binary number. And then I insert 4 of these iterative comparator in one circuit and cascaded it together to compare two 4-bit binary numbers, which are A and B. The output from this circuit is Eout and Gout. Eout will be high when the value of A and B is equal, while Gout will be high when the value of A is greater than B. So this is the compilation report for the comparator, just to show that our circuit is okay and we can run it successfully. And here is the simulation waveform for the comparator. As we can see, we for the A value, we insert the value from 0 until 15, and for the B value, we insert the value of 1011 in binary or 11 in decimal. This is to we choose this value because it is stated in the question. So as we can see, from 0 to 10, E out and G out is 0 because the A value is less than the B value. When the A value is 1011, which is equal to the B value, then E out will be high 1 and G out will be 0. And after that, the A value will be greater than B, which is 12, 13, 14, and 15. So the G out will be high during that time and E out will be 0. Here is the binary to BCD converter schematic diagram. This circuit is made from two modules, which are CADD3 and also 7447 IC. CADD3 stands for conditional adder, which function to add the value of 3 to the given input, and the 7447 IC is BCD to 7 segment converter. The output from this circuit is A to G and also BC. Since we will count from 0 until 15, so we need to have two 7-segment display. A to G output will be supplied to the first 7-segment display, while the BC output will be supplied to the second 7-segment display. So next we will take a look into the compilation report. This compilation report is just to show that our circuit is successful, so we can run the circuit without any error. So here is the simulation waveform for our circuit for the binary to BCD converter. From here, we will supply the input with the 4-bit binary number in base 16, which is from 0 until F. So we can look from this waveform that BC output will only show the value of 0 or 1. This is because we will count from 0 until 15. So the 10th value will only show 0 or 1.
This is input filter. As you can see, we have two NOT gate, this one, and we have one AND gate, this one. The function of input filter is to filter the glitches to turn the multiple signal into one single input. Next, this is the compilation for the input filter, and it is successful. As you can see, this is the waveform of input filter. For the selector, we use two 4-bit multiplexer, and for the input A, we connect it to the ground, and for the input B, we connect it to the VCC. Switch 1 will on if the input given is 2, which is 0010, and switch 2 will on if the input given is 5, which is 0101. And this is the compilation report for the selector, and it is successful. This is the waveform for the selector. As you can see, when the switch 1 give 1 input, it will produce the output of 2, which is mean when switch 1 is on, the output given is 2, When switch 2 is on, the output given is 5. Then it's keep repeated.
Yay! Finally, we have finished building all the modules that needed for our vending machine. So now, we just need to connect all the modules into one schematic diagram and compile it to see if it is free from errors. So here's how we connect all the modules, and the comparison report shows that our circuit is successful, which means we can build the circuit without any error. Supposedly, we should connect all the circuit into a real hardware, but due to COVID-19 and all the hardware is at UTM, so we didn't have the chance to connect the hardware properly. Inshallah, in the next time, if we have time to connect the hardware, we can show you the final the final result of our project. So thank you for being with us.